Hey, Yes. Good afternoon, dear students. Yes. So in the last class, we had started with aldehyde ketones and carboxylic acid, right? So we have discussed some 18 question, right? So we have discussed some 17, 15 to 17 questions. So, okay. So till here we have completed yesterday. So today we are going to start with the remaining question. Okay, so the same chapter we are going to continue. That is aldehyde ketones and carboxylic acid. Okay, so let us start. Okay, so this is a question. Okay, so ketones. Okay, ketones are represented by R, C double bond O, R dash. Okay, where R and R dash are your alkyl groups. Okay, R and R dash both are your alkyl groups. So these this particular group, it represents what? This represents your ketones. Okay, so this can be obtained in one step. Why? So how it can be obtained in one step? So A, oxidation of primary alcohols, then B, hydrolysis of esters, C, oxidation of tertiary alcohols, and D, reaction of acid halides with alcohols. Yes. How the ketones are obtained in one step? How will you answer this? Yes. How will you answer this? Yes, you can use the chat box for answering. Okay. Vedvati has answered it as B. Others? Okay, Madan has also answered as B. Okay. So, and ester is point. Okay, we have seen which question. Yes. 36. Okay, ketones. So here, now, how you obtain this ketones? Okay, we know that, remember that. So whenever you have primary, this alcohol, okay, whenever you have primary alcohol, so primary alcohol, when you do oxidation, what you will get? You will get aldehydes. What you'll get? You will get aldehyde. Okay, and whenever you have secondary alcohols also will give you this aldehyde. But when you have a tertiary alcohol, okay, whenever you have a tertiary alcohol, and this tertiary alcohol should be what? It should be a this tertiary alcohol when you do oxidation with a stronger oxidizing agent. Okay, when you have a stronger oxidizing agent, so what will happen? Go your OH group. Okay, so this will form ketone. So what you will get? You will get a ketone. Okay, you will get what? You will get a ketone. So it will be given out as CO2. Okay, plus water molecule is left. So water molecule is removed. So it is option number C. It is option number C. Okay. So that is when oxidation of tertiary alcohol. So oxidation of tertiary alcohol will give you what? It will give you ketone, and it will eliminate as carbon dioxide and water molecule. Okay. So this is the reactions of ketones. Okay. So remember that ketones will be obtained in one step when you do oxidation of tertiary alcohols. Okay. Next question. Which of the following is incorrect? A. NaHSO3 is used in detection of carbonyl group. B. FeCl3 is used in detection of phenolic group. C. Tollens reagent is used in detection of unsaturation. And D. Pelling solution is used in detection of glucose. Yes. So which of the following is incorrect? Okay, so these are the different tests and where it is used. So it is given. So you have to tell which is not correct among the following. So NaHSO3, okay, NaHSO3, it is used in detection of carbonyl compound. Yes, okay. So this test is correct. So when you treat your carbonyl compound with NaHSO3, okay, this what your carbonyl group, it is substituted. It will undergo a addition, okay, nucleophilic addition reaction. Then FeCl3, it is used in detection of phenolic group. Yes, this is also correct. This test is also correct. Now, Felling solution, it is used in the detection of glucose. Okay, so this is also correct. Tollens reagent is used in what? It is detection of unsaturation. What do you mean by unsaturation? It tells you about the presence of double or triple bond. Okay. Now, this test. It is shown by what? It is shown by KMNO4 BR2. Okay, that is Bayer's test and not Tollens test. Tollens test, it is used for detection of what? It is used to detect the aldehydes, presence of carbonyl group, okay, in the aldehyde. So that is C double bond OH group, okay. So Tollens reagent, where it is used in the, it is used in what? It is used in the detection of your aldehydes. And what is Tollens reagent? Can anyone tell me? What does Tollens reagent comprise of? What it contains of Tollens reagent? Anybody? Yes, Tollens reagent. What does it consist of? It is a solution made up of what? Ammonical silver. Right. Please remember this. Ammonical solution of silver nitrate. Okay. Of silver nitrate. Silver nitrate. So ammonical solution. Ammonical means ammonium hydroxide. Okay. Ammonical solution of silver nitrate. Yes, very good. Vedvati has answered ammonical silver nitrate. Very good. So ammonical solution of silver nitrate. So when we have aldehyde, okay, when we have a aldehyde and when you treat it with Tollens reagent, okay, and you treat it with Tollens reagent. So what is formed? Silver oxide is formed. Okay, silver oxide is formed, and this silver oxide, whatever is there, okay, sorry, this silver oxide, what the Tollens reagent, that is silver oxide, which is there, it gets reduced. Okay, it gets reduced to what? Metallic silver. Okay, it gets into metallic silver. Okay, and this will deposit as what? It will get deposited as the this what? Silver mirror test. Okay, it is called as a silver mirror test. So like a mirror, you get the solution. Okay, so this Ag, what it gets deposited, it will be in the form of silver mirror. Okay, like mirror form. So it is C. Tolerance reagent, it is used in detection of your what? It is used in the detection of aldehyde and not in the for unsaturation. Unsaturation, the test is Bayer's test. Okay. Next question. A and B in the following reactions are. A and B in the following reactions are. Okay. So a ketone is there. With this ketone, you are going to react it with KCN or HCN. You get a product A. This A on further treatment with B will give you this product. Okay. So let us follow the steps and find out what are A and B. So I have a ketone. Okay, I have a ketone. Okay, I have a ketone. I am treating it with what? I am treating it with HCNN. KCN. Okay, I'm treating it with HCN and KCN. So what I'll get here, it will undergo a nucleophilic addition reaction. So at this carbonyl carbon, okay, at the carbonyl carbon, okay, so this is there, right? So your OH will form. So, okay, so this bond will break, that is C double bond O, and it will form COH and R dash and R dash, and at this you will have CN. Okay, so I'll show you. Just see. So how is the reaction? I'll show you. Just a second. I'll take another color. So Cn minus and H plus. So Cn minus will attack this and it will polarize this bond. So what is formed? So R, C. So Cn will attach here. So this will be minus. This will be R dash. So whatever the proton is there, that will go and attack here. So it will form OH. Okay. So this is your product. Then, so this is our product A, right? So this is our product A. Now this A, further, I'm going to treat it what? B. Okay, what is B? So I have got, okay, they want to know which is the reagent. Okay, they have given the product already. So R, C, OH. Okay, so rest all is same. Only your CN has been converted into CH2, NH2. Okay, it has converted into CH2, NH2. So which is the, so what changes you can see? There is an addition of hydrogens, right? Addition of hydrogen. So now I have to see which is a hydrogen means it is undergoing reduction. It is undergoing reduction. So I have to use a reducing agent. I have to use a reducing agent. So among the following, which is a good reducing agent? It is lithium aluminum hydride. So lithium aluminum hydride is a good reducing agent. So we are doing reduction by using lithium aluminum hydride. So option number A. Okay, let me see who all have answered it as A. Okay, Vedvati has answered it as A. Okay, yes, Madan has also answered it as A. Very good. Okay, so let us continue with the next questions. Which of the following represents the correct order of the acidity in the given compounds? So just go through these different compounds and their order, okay, of acidity given. So you have to tell the correct one. So you have to choose the correct order. So they have given different orders. So you have to choose the correct among the following. Yes. Yes. What is the answer? So we know that, okay, there is a order of acidity. Represents the correct order of acidity. So which is highest? So they have given the decreasing order. They have given the decreasing order. Okay. So this is more than this least. So they have given the from increasing to okay. So it is they have given the decreasing order. So which is the decreasing order of acidity among the following? So we know that whenever we have electron withdrawing groups, okay, whenever we have electron withdrawing groups, okay, or electron withdrawing substituents, what will happen? It will increases the acidity. It will what? It will increases the acidity. Okay. How it increases the acidity? By increasing the ionic character. By increasing what? Ionic character. Okay. By increasing the ionic character of what? Your OH group. So of your OH group, as you are increasing the ionic character of OH group, that is by inductive effect. By inductive effect. Okay. Now, what is inductive effect? It will occur due to the presence of your electronegative atom. Now, F, CH2COOH. Then you have CH3COOH. Then you have BrCH2COH. Then you have ClCH2OH. Okay. Now, you can see, so there is a, here there is a negative atom, here there is an electronegative atom, here there is an electronegative atom. So because of the presence of these electron withdrawing substituents, they will withdraw the electron towards itself. Okay. So what will happen? There will be increase in the acidity, right? So what will happen to the electronegativity? Electronegativity will decreases. Okay. Though, so fluorine is the most electronegative element. So as we know, when we write the write the this, okay, chlorine comes first, chlorine comes first, then comes sorry, chlorine comes first, then comes your chlorine, then comes your bromine, and then comes your iodine, right? Now fluorine is the most electronegative atom, then comes your chlorine. So fluorine comes first, then will be your chlorine, then will be your bromine, and then will be your CH3. So which is the correct answer? C. So CH3 is your, then comes your bromine, chlorine, and fluorine. So option number C. Yes, others? Yes, please answer. Okay, please answer. So here, so whenever you have electron withdrawing group, electron withdrawing group, what will happen? Because of electron withdrawing group, the acidic character increases. Okay. Now, how it will increase? So as we are discussing about the electronegative atom, because of presence of electronegative atom, there will be what inductive effect experienced, right? Because of the presence of this electronegative atom. So fluorine is most electronegative, iodine is the least electronegative. So based on that, we have written the order. So fluorine comes first, then chlorine, then bromine, and then your methyl group. Okay. Next, in which of the following the number of carbon atoms does not remain same when carboxylic acid is obtained by oxidation? So in which of the following? So first is a acetone. First is acetone. Second is CCl3, CH2, C double bond OH. Okay, so this is a trichloropropanic acid. Okay, so you have what? So you have that is a aldehyde. It is not acid. So trichloropropanoaldehyde. Okay, then here you have what? 1, 2, 3. So it is a CH3, CH2, CH2, OH. So it is a propane to propanol. Okay, it is a propanol. Then you have CH3, CH2, CHO. So this is propanaldehyde. Propanaldehyde. Aldehyde. Hmm. So now here, so acetone. So how we will write here? So which of the following the number of carbon atoms does not remain same when carboxylic acid is obtained by oxidation? So if I do, so we know that, okay, now we have a ketone. Okay, so ketones on oxidation. So if I do oxidations on ketones, okay, what you will get? You will get, what you will get? So you will get acetic acid. Okay, you will get acetic acid. So I'll get a what? I'll get a acid here. Okay, carboxylic acid plus CO2 plus H2O. Okay, so whenever I have a acetic acid, so what I'm doing? So at this bond, I'm adding one more oxygen, right? So here this will leave as CO2 and this will give you this, right? So you will get, so ketones on oxidizing, okay, it gives carboxylic acid with lesser number of oxygen. It will give lesser number. So you can see there are three carbon atoms, but here there are two carbon atoms. Okay, so it does not remain the same. It does not remain the same. Okay. So the number of carbon atoms, okay, so which will be not same is in A, option number A. Sodium formate on heating yields. Sodium formate on heating yields A, oxalic this what oxalic acid and H2, B sodium oxalate and H2, C carbon dioxide and NaOH, and D sodium oxalate. So what is sodium formate? COOH is formic acid. Okay. Now if sodium formate means what? One of the hydrogen is replaced by sodium. So it will be HCOONA. So when I take and I heat it at 360 degrees Celsius, what I'll get? I'll get sodium oxalate. Okay, I'll get sodium oxalate. So again, both of these hydrogen atoms are replaced by what? It is replaced by your Na. Okay, so I'll get sodium oxalate plus H2 plus H2. So option number B. What is the correct answer? Option number B. Okay, option number B. Okay. Formic acid is obtained when? So when does formic acid is obtained? Yes. A. Calcium acetate is heated with concentrated H2SO4. B. Calcium formate is heated with calcium acetate. C. Glycerol is heated with oxalic acid at 373 Kelvin. And D. Acetaldehyde is oxidized with potassium dichromate and H2SO4. Okay, Vignesh has answered it as D. What about others? Others are sleeping or what? Yes, there is no reply. Formic acid is obtained when? Okay, so Madan has also answered it as D. Okay, others, others, others. Yes. Okay, so let us see. So formic acid, just now I told you HOOH. So how it is obtained? Okay, now suppose I have a glycerol. Okay, I have a glycerol that is CHOH and CH2OH. So this is what? This is my glycerol. So this glycerol, if I react it with oxalic acid, with what? If I react it with oxalic acid. So this is my oxalic acid. Okay, oxalic acid at a temperature of 100 to 110 degrees Celsius. So what will happen? There will be loss of water molecule. There will be loss of water molecule H2O. Okay, so what I'll get? So CH2O C, okay, and COH. Okay, so this will get attached here and I'll get CHOH, then CH2OH. Right. So here what you'll get, just see, I'll show you. So your H will leave and okay, so what you'll get CH2O COOH, which is the COH, this COH. Okay, so COOH. Now this on further, there will be carbon dioxide. Okay, what I'll do, I will remove the carbon dioxide from here. So CO, I will show this properly. So what I'll get here, so CH2, okay, then O, then what? CH2O, C, okay, and COOH, right? So now what I'll get? So I'll remove this carbon dioxide. So what it will be? CH2. So this will be removed as carbon dioxide. CO2. I'll take here. Okay. So how I'll get? CO2. CO2. So what I'll get? So CH2 and CHO. Okay. So it is left as what? It is left as carbon dioxide. So it is CHOH and CH2OH. So this further, what will happen? There will be hydrolysis. Okay, hydrolysis takes place. That is, hydrolysis takes place to give you what? Hydrolysis. It undergoes hydrolysis to give you CH2OH. Okay, CH2OH and your CHOH and CH2OH plus HCOOH. Okay, so your CHOOH. So this is your formic acid. So this is the reaction. Okay, this is your reaction. So CH2, okay, CH2O. So add oxygen. What is happening? Okay, your this is added. So H2O. Okay, H2O. So it's like this. So one molecule of oxygen is added here. One molecule of oxygen is, okay, it is added at this molecule. So you'll get what? You'll get formic acid and glycerol back. So this is your glycerol. All right. So what is happening here? So we are heating the glycerol with oxalic acid, and these are the reactions which takes place. So you get option number C. So formic acid, how it is obtained? It is obtained when you heat it with oxalic acid. Okay. So let us go for the next one. Which one of the following esters cannot undergo Claisen self-condensation? Which one of the following esters? So first we'll see what is Claisen self-condensation. What is Claisen self-condensation? Yes. So intermolecular condensation. So it is a intermolecular condensation, okay, between two different molecules. So intermolecular condensation. So when two molecules are getting condensed, okay, that is the esters. So what, which contains alpha hydrogen, which contains what? Alpha hydrogen. So what is the criteria? So two esters should be there, and this will undergoes, that is two different esters, two different esters, molecules of esters, and it should have what? It should have a alpha hydrogen atom. Okay, alpha hydrogen atom, and there should be a presence of strong base. Presence of what? Strong base. So there should be presence of strong base, and what it should form? It should form a beta keto ester. Okay, at beta position, there should be a keto group and ester group. So this is the product obtained in Claisen self-condensation. So what is Claisen self-condensation? Intermolecular condensation of two esters, which should have alpha hydrogen atom, okay, in the presence of a strong base to give you what? Beta keto ester. Okay, so let us see now what will be the answer. Okay, so if I take one as what? So if I take, so here, okay, so in which molecule I have a beta, that is a alpha hydrogen, okay, alpha hydrogen. So next to a C double bond OH group. Okay, so alpha hydrogen, but I should form what? It should undergo self-condensation. So same two molecules should be present, okay, same two molecules should be present. So if I take this, your C6. So now here, which is not having a alpha hydrogen, right? So here now, what is the question? Which one of the following will not undergo alpha condensation, right? So here it should not have a alpha hydrogen, that we have to see. Now here there is a presence of alpha hydrogen. So this will undergo Claisen self condensation. Now here after C double bond O, there is a presence of alpha hydrogen. So this will also undergo Claisen self condensation. Then after C double bond O, okay, here also you have a CH2 group. Here also there is a presence of alpha hydrogen. Now in this C6H5, C6H5, C double bond O, O, C2H5. Do I have alpha hydrogen here? No. So option number B. Yes? Right. So option number B is the correct answer. Is it correct? Yes. So option number B. Understood? Yes. Is it clear? So option number B. So what is Claisen self-condensation? It should undergo intermolecular condensation, okay, of two esters, which should have alpha hydrogen atom. In the presence of strong base, it will form beta keto ester. So the criteria is that it should have a alpha hydrogen atom. Here in all the three other options, you can see there is a presence of alpha hydrogen, but in B options, you don't have a alpha hydrogen. So B is the uh, ester which will not undergo self condensation. Okay, so let us go for the next one. During reduction of aldehydes and with hydrazine and potassium hydroxide, the first is the formation of. So during reduction of aldehydes, so when we are doing the reduction of aldehydes, with hydrazine, NH2. Okay, NH2 is what? Your hydrazine. So I have a aldehyde. Suppose I take aldehyde. This aldehyde, I'm going to treat it with hydrazine. So this is my hydrazine. This is my aldehyde. So what I'm doing, I'm taking aldehyde, I am treating it with hydrazine. So what I'll obtain? So I'll obtain CH. Okay, so NH2. So this will go and attack at this carbonyl carbon. So what I'll go get? So this will cleave to form you. Sorry. So here CH. Okay, this will so this your CH bond. Okay, then what you will get attached? Your nitrogen. Okay, so nitrogen, so it should have a triple bond. Okay, so N of this hydrogen and NH2. So like this. Okay, like this. So what it will go? It will go as a water molecule. So this your oxygen and your 2H2. So this will go as what? This will go as your water molecule. You can see. So this oxygen and your these two hydrogens. Okay. So they'll go as a water molecule and RCH double bond N NH2. Okay. So this will be your product. That is, it is a aldehyde hydrozone. It is what? It is a aldehydic hydrozone. Okay. Hydrozone. Hydrazone. Okay. Hydrazone. I'll write the spelling correct. So aldehyde hydrazone. Okay, so when you have double bond and NH2 group. Okay, so aldehyde and hydrazone. So this is the, so which is the answer here? Which is the answer? CHNNH2. So option number A. Yes, Madan has answered. Very good. Okay. What about others? I want answers from all of you. Okay, so please answer. Next is nucleophilic addition reaction will be most favored in. So where does nucleophilic addition reaction mostly favored in? Yes. So these are the four options. So nucleophilic addition reaction in which, so you have a ketone, you have a aldehyde, and this is a ketone. Okay. So this is a acetone, this is a propanaldehyde, this is a ethanaldehyde. Okay. This is a ketone, methyl propyl ketone, right? So which will be most favored in your nucleophilic addition reaction? So remember that for nucleophilic addition reaction, okay, for undergoing nucleophilic addition reaction, there should be what? They will show plus I effect. Okay, so plus I effect. Now this plus I effect should be present with, will be due to the presence of CH3 group. Okay, it will be due to presence of CH3 group. Now suppose, now when if I consider the first one, that is your acetone. If I consider the acetone, now here I have two CH3 groups. What I have two CH3 group. So this CH3 group, what will happen? They will reduce the positive charge density on this carbonyl carbon. They will reduce the positive charge density. Okay, positive charge density. What happens to that? It is reduced. Okay, it is reduced. Okay, on the carbon atom of carbonyl group. So this is with respect to your acetone. Now, in the this more inert carbonyl, so whenever you have okay, so your carbonyl group, right? If you see this carbonyl group, what is there? The bulkier groups are there. Okay, bulkier groups are there. Means what is happening? The attack is a bit tedious. Okay, the attack is not possible because there are bulkier groups. So it will become less reactive. So this is also wrong. So option A and option D is discarded. Why? Because in the option 4, you can see there are more bulkier groups are present. So because of the presence of more bulkier group, what will happen? This particular ketone, it will be less reactive. Now here also, if I consider, now there are two more. Okay, one is your CH3CHO and another is CH3CH2 C double bond OH. Now if I consider these two, which is less substituted, so here the attack is possible. Okay, here it is more reactive as compared to this. This is less reactive because again bulkier group. Okay, as compared to your methyl group, this is a bulkier group. So option number C. Okay, option number C is the correct answer. So what will happen here? Okay, so this is the hindrance. Okay, aldehydes will be more reactive than the ketones because of the plus side effect of CH3 groups. Okay, is it clear? Next question, which of one of the following compounds will be most readily dehydrated? Which of the compound will be most readily dehydrated? Yes, which of the compound? Yes, what is your answer? So CH3, C double bond O, CH2, COH, CH2, and CH3. Okay. Most readily dehydrated. Dehydrated means it will be removed as a water molecule. Okay. Now here, if I consider this D option, okay, the intermediate formed here will be what? So if I remove this, so if this water molecule is left, okay, and if the water molecule is, so if the H plus ions, okay, this will attack the H plus ion, okay, and it will form water and it will form a positive charge. So this is what? 1, 2, right? This is a uh, secondary LDL, sorry, secondary carbocation. Right. So this carbocation formation, whatever is formed here, it can be destabilized. Okay, it can be destabilized because of the presence of this carbonyl group next to it. Okay, because what you can see, there is a alpha carbon also present next to the OH group. Okay, next to the next to the CH that is C double bond O and OH group, you have a alpha carbon. So because of that, what you can do, it can be destabilized. So alpha hydrogen is present. So when you know that alpha hydrogens are more acidic, right? Alpha hydrogens are more acidic and it can be removed as water. So the positive charge which is formed on the this what in your into this positive charge which is formed on the carbon, it can be stabilized by this alpha hydrogen. If I consider option A, okay, option A. Now, if this goes as a water molecule, now here again there is a positive charge. So how you can stabilize it? Yes, how you can stabilize it? This alpha hydrogen. But again, this will be polar. This no, it will disturb this carbon. So this is not possible. Here also it is not possible because you have a water molecule, okay, and next to that you have a carbonyl group. So there is a no presence of alpha hydrogen, okay. And the stability, if you see the stability, okay, so this is what this will be again. So if you remove this as water molecule, okay, so here it will be what carbocation? It will be a primary carbocation. So again here, if you see what is there, again it will disturb the stabilization of the carbonyl compound. So option number D. Option number D is the correct answer. Okay, option number D. Is it clear? Yes. So next one, the order of reactivity of phenyl magnesium bromide with the following compounds. So these are the following compounds. Okay, so what is the order of reactivity of phenyl magnesium bromide? So phenyl magnesium bromide is C6H5 MgBr. Okay, that is a Grignard reagent. So with what will be the order of reactivity? So if I have a CH3C double bond OH. Okay, that is when I have a aldehyde. And if I react it with C6H5 MgBr, what I'll get? I'll get CH3C. Okay, this will be H. Then I'll get OH. Then I'll get C6 OMgBr. Okay, and I'll get C6H5. So this is one. Then with CH3, C double bond O CH3, if I react, then I'll get here what? I'll get here C6H5 OMg. Br. Okay. Yes, last one. I will write that. Right. So if you hydrolyze, this will be OH. So MgBr will go and we will get a OH. Now again, here next one is phenyl groups. So phenyl C PH. So OMgBr, and this is C6H5. Now here, what is the order of reactivity? Now here you have three phenyl groups. So here the steric hindrance will be more. The attack, okay, it is little difficult. Now here you have two methyl and one phenyl group. Here you have one methyl, one phenyl, and one this. So what will come first? Yes, first will be your this compound. First will be a this compound, then will be a this, and next will be your this. So the order of stability, your this compound, okay, that is your aldehyde compound, okay, it will be more stable because you have one hydrogen, okay, only one methyl group is present. But as you are going here, two methyl groups, and here two phenyl and one phenyl, okay, so three phenyl groups. So it will be much more crowded. So option number D. Okay, option number D is the correct answer. Okay. Yes. Next one, match the following given in list 1 with list 2 and select the suitable options using the code below. So which is the different, you can match the compounds, okay, in list 1 with the suitable options in list 2. And you can give the answer. Yes. So if I have a benzaldehyde, okay, that is 2C6H5CHO. So if I treat it with KCN in the presence of H2O and ethyl alcohol, okay, I'll get what? I'll get C6H5C double, one will be C double bond O, okay, then CH, C6H5, OH. So this is what? This is a benzoin. This is a benzoin condensation. So when two molecules of benzaldehyde reacts with KCN in the presence of water and ethyl, okay, ethyl alcohol, what you will get? You will get a benzoin condensation. So you have one hydroxy and one keto group, okay, in the same molecule. So option number A will be with B2. Okay, then phthalic anhydride. Next is phthalic anhydride. What is the structure of phthalic anhydride? So let me write the structure of phthalic anhydride. So this is a phthalic anhydride. So when I have phthalic anhydride, okay. So phthalic anhydride, if you treat it with your this what? Mm, phenol groups, OH. Okay, two phenol groups, OH. So the hydrogens, okay, and your oxygen will get combined, and okay, in the acidified reaction, what you will get? You will get the structure of phenolphthalein indicator. So when you react your acid, phthalic anhydride, so this is a phthalic anhydride. So when this phthalic anhydride reacts with your 2 moles of phenols, okay, in the acidic conditions, what you will obtain? You will obtain C double bond O, okay, then like this. So this will form, so this will get attached here. So OH, and here you will get OH. Okay, so this is a phenolphthalein. Okay, this is what? Phenolphthalein. So option number B is first one. Then phenyl benzoate. So what we can do with phenyl benzoate? So we have two more options. One is oils of wintergreen and Fry's rearrangement. Okay. Now this phenyl benzoate. Okay, phenol benzoate. What happens with phenol benzoate? Phenol benzoate, it will undergo what? It will undergo this. What it will undergo? It will undergo a phenyl and benzoate group. Okay, so what it will undergo? Fry's rearrangement. Okay, it will undergo Fry's rearrangement. So this answer we go, and methyl salicylate will undergo oil of winter. Okay, so it is called as the oil of winter green. So which is the correct answer? It is option number D. Option number D. Is it clear? Okay, so last question. Which of the following types of isomerism is exhibited by pentanone? Which of the following pentanone? So let me write the structure: CH3, 5 carbons. Okay, CH2, CH2, C double bond O, and CH3. So what type of isomerism is exhibited by pentanone? So this, and if I write like this, it can be CH3, C double bond O, CH, CH3, CH3. Okay. So this 1, 2, 3, 4, 5. So these are what? These are the what you can see. What you can see here. So the chains are different, right? So these are examples of chain isomer. So the chains are different. The mode of attachment is different. So these are the chain isomer. Then again, what is possible? So CH3, CH2, C double bond O, CH2, CH3, and again is possibility C double bond O, CH2, CH2, CH3, 1, 2, 3, 4, 5. So this is what? This is a position isomers. Okay, position isomers means what? Position isomers means isomerism is what? Here the functional group position is different. So here it is 1, 2, 3, and here it is 1, 2. So third, 3 pentanone, this is 2 pentanone. So the position of the, this is different. Now, one more possibility is CH3, C double bond O, CH2, CH2, CH3, and CH3, CH2, 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 C double bond O, H. So see now, the number of, that is the molecular formula is the same, only the functional group is different. So this can be a functional isomer. So what is pentanone? It will show chain isomerism, position isomerism, functional isomerism. So that is all of the above. Okay, so option D. Is it clear? So option D. Fine. So yes. So these were some of the questions based on your aldehyde, ketones, and carboxylic acid. Any doubts here? So this completes the chapter aldehyde, ketones, and carboxylic acid. Okay. I hope okay, you have the notes. Yes, Madan had asked for the notes. So morning section in the groups, this is sent, no? What is that? Synopsis. CT notes. So in the form of this. Okay, synopsis is already sent for you. So go through the synopsis. Okay, and then what you can do, you try to solve the questions from different books. Okay. And as you know, after this class, okay, so links will be sent for you. Google form links will be sent. So take that as a test. Okay. And try to evaluate yourself. Okay. Fine. So you can solve more questions. Okay. What you can do, you can take some other books and try to solve some more questions so that you will see how much you have understood. Okay. So any doubts? Yes. Anything you want to ask? Yes. Anything you want to ask? Everything is clear? Yes. So today we have completed aldehyde, ketones, and carboxylic acid. Okay. So tomorrow we are going to see the next chapter, that is amines. Okay. We are going to see next chapter, that is amines. Okay. Fine. Okay. So I hope everyone has understood. So please solve much questions. Okay, take some books or take some previous question papers and solve the questions so that it will help you. Okay, to understand the things more clearly. Okay, so fine. So I'll end the session here. Okay, so we'll meet in tomorrow's class. Thank you.